5.6, graphing linear inequalities in two variables. Okay, so on these examples down here, this is a linear inequality. It has two variables, an x and a y. Same thing here, okay? And the first thing we're going to do is test whether these points are going to be solutions to these inequalities, okay? And the way we're going to do that is substitute this x and y into the inequality, okay? So I'll put -4 in for x and -1 in for y. Good idea to use parentheses always when substituting. Okay, so I substituted. Now I'm going to simplify. So let's see, 5 times -4 is -20, and -2 times -1 is +2. And then I want to simplify on the left. -20 plus 2 is -18. And once I've simplified, I've got this statement, and I'm going to decide, is that true or false? If it's true, the ordered pair is a solution. If it's false, the ordered pair is not a solution. Okay, so -18 is less than or equal to -1. Well, that is true because -18 is less than -1, right? So this is a true statement, which tells me that yes, that ordered pair is a solution. Okay. It's not the only solution because there's actually an infinite amount of solutions, but we'll get to that later on. Okay, so let's try another here. I'm going to plug in this xy pair. So let's see, -2 times 5 minus 3 times -7 is less than 15. All right, let's simplify this so we can see if this is true or not. -2 times 5 is -10. -3 times -7 would be +21. Okay, and then -10 plus 21 is going to be 11. And I've got 11 is less than 15. That is also true. And so that means that, again, yes, this is a solution. If you got a false statement, you'd have no. Okay? All right. So next, let's look at graphing a linear inequality in two variables. Okay? So this is what's going to happen on this problem down here. We're going to be graphing this inequality, and part of it's kind of similar to graphing the line y equals 1/2 x minus 3. Okay, so I'm going to graph the boundary line using the related equation. So I'm going to think, well, what would this look like graphed if it were just an equation? But there is a little difference. I'm going to use a dashed line if I've got one of these two symbols. And I'm going to use a solid line if I've got one of these. So this particular example down here, this one, I'll use a solid line. Okay, so let's get to the graphing part. So if I'm thinking about this as an equation, this is in y equals mx plus b form. So that's handy for graphing because I can see that the slope is 1/2. And the y-intercept is -3. So I'll start with the y-intercept at -3. That's where my boundary line is going to cross the y-axis. And then from that point, I'm going up 1 to the right 2 to get to another point. And I could keep going up 1 to the right 2 all the way. Or I could go down 1 to the left 2 because this is the same as -1 over -2. Okay. And then this is the part where you want to be careful. Sometimes you might need a dash line. This one is solid, so I'm going to draw in that line. Okay, so I've got this line drawn. But what I want to do is I want to indicate all of the solutions. So there are a bunch of different xy pairs that will satisfy this inequality. I can't list them all because there's an infinite amount. But what I can do is graph them. So I want to split the world into two. I want to split it into the points that are solutions to this and the points that are not. And this boundary line is where the world's going to get divided. Okay? So I'm going to shade either this region or this region. The region that I shade is going to be all of the solutions. Okay, so I might shade up here, I might shade down here. Okay, so one way you can figure that out is to pick a point that is not on the line And my favorite point to pick is 0, 0. The only time I wouldn't pick 0, 0 is if 0, 0 is on the boundary line. Okay? And I'm going to use this as a test point. All right, so I'm going to do a little test here. I'm going to test 0, 0. I'm going to plug it into the inequality. So I'm plugging in 0 for both x and y. And I'm going to see if I get a true statement or not when I simplify this. The reason I like to use 0, 0, it makes the math pretty easy because 1/2 times 0 is just 0. And then I've got 0 is less than or equal to -3. Well, that is a false statement. Okay, so that means that this test point is on the false side of the boundary line. So there's a false side and a true side. So if this region is the false region, that means this one is the true region. Okay, and I want to shade the true region. So that means any point I choose down here should satisfy the inequality. So if you want to test it out, you could pick like the point 4, -3, for example, plug it in, and you should get a true, it would be a true statement. So I'm going to shade the true side, and that's where all of my solutions are. Any point on this non-shaded side is not going to satisfy the inequality. Okay, so there I just split the world into two. There's also a little shortcut that you can use that I'm going to show you. If you've got your inequality in y equals form, so if you've got y on the left and then everything else is on the right, if it says less than or equal to, then you're going to shade below the line. That's what I did here. If it says y is greater than or y is greater or equal to, then I would shade above. But if you forget how to use that or you're not sure about it, you can always do this with a test point as well. Let's look at some more examples. All right, so this one, I'm graphing this. By the way, if the directions were solved, I would do the same thing. I would have to graph it because I couldn't list all the xy pairs that are solutions. It's an infinitely long list. Okay, so I'm thinking about graphing the related line here. So I'm thinking about graphing this. Okay, and you could do this with x and y intercepts. I personally would put this in y equals mx plus b form. So that's what I'm going to do so that I can see the slope and the y-intercept. So I want to isolate the y on the left. Okay, and so now I've got 3y equals, I could write 3 minus 2x, but I'd rather put the negative 2x in front of the 3 so that it's closer to y equals mx plus b form. And then I'm going to divide everything by 3 to isolate the y. All three terms, the whole equation I'm dividing by 3. So now I've got negative 2/3 x plus 1 on the right side. Okay, so when I'm thinking about graphing this, now I can see, okay, my slope is negative 2/3, which I could think of either of those ways. So you could put the negative on top or the bottom. You could leave it in the middle too, but I'm just thinking rise over run. I'm going to use rise over run, so I'm thinking that format. And my y-intercept is 1. So I've got a y-intercept of 1, okay? And then I'm going to go down 2 to the right 3, down 2 to the right 3 from my first point there, and down 2 to the right 3. Or I could go up 2 to the left 3, up 2 to the left 3, up 2 to the left 3, okay? And now it's really tempting to just draw my line through that, but I've got to be careful because this is actually going to be a dashed line. Okay, so when I draw this, I need to be careful. Solid line is different. So I actually didn't talk really about what the difference between solid and dashed means. So I'm going to still shade one side of this line. But when it's a dashed line, it means that points that are on the dashed line are not part of the solution. Whereas if I had a solid line, the points on the boundary line would be part of the solution. Okay. All right. So I need to figure out shade above or below. And so I'm going to pick a test point, and I can see 0, 0 is not on the line. So I'm going to use that as my test point. I'll use this area over here. Okay, I'm going to go to the original inequality. I don't want to use the equation. I want the inequality. I plug that in for x and y. And I want to see if this is true or false. So that's going to be 2 times 0 is 0, 3 times 0 is 0. So the left side I've got 0. I got 0 is greater than 3. Well, 0 is not greater than 3. That's a false statement. So that means my test point is on the false side. That means the other side should be the true side. That's the side then that I'm going to shade. All of my solutions should be up there. So you could pick another test point up here to try it out, and it should satisfy the inequality. Also, if you wanted to use the shortcut version, then you'd have to think about y equals, when I got the y equals by itself, which would have been just like this. So if you put this into y equals mx plus b form, you would have, this says y is greater than, which means you're shading above the line. Okay, so it does work out with that shortcut. With that shortcut though, sometimes if you multiply or divide by a negative, you got to flip the inequality symbol, so you got to be careful of that too. So maybe it's safer to just use the test point, but if you're confident, you could use that shortcut. Okay, all right. Let's get to these two. I see these problems aren't particularly difficult, but a lot of times people mix these up. So I'm thinking first off, well, this is going to be a dashed line because the inequality symbol isn't underlined. This one would be a solid line, right? So I'm keeping that in mind. And then I'm thinking, okay, y equals -2. What's that going to look like? A lot of times I'll see people graph a line something like this for y equals -2. But that's not what it looks like. So if you're not sure if it's horizontal or vertical, what you can do is make up a few different points that have a y coordinate of -2. You can put anything you want in for x. So I'm just thinking, I'll just keep it simple for the x's. I did 0, 1, and 2. So let's plot those points. I got 0, -2, 0 to the right, 2 down. I got 1, -2, 2, -2, and pretty quickly I can see that this is going to be a horizontal line. Okay, now I want to make that dashed. Okay, and then you can do this with a test point still. So I can plug in 0, 0, and I'm really just thinking, when I do my test here, I'm thinking, okay, I'm going to plug that in for x and y. There's nowhere to plug in the x, so let's just plug in the y. And then, is 0 greater than -2? It is, right? So that means the test point is on the true side. That means this is the part that I'm shading. All of my solutions are going to be above that line, which makes sense because any point up here would have a y coordinate that's greater than -2. Any point down here would have a y coordinate that's less than -2. Okay? All right, so let's think about what x equals 3 looks like. That would be the boundary line, and I want to make it solid here. So I'm going to make up some points where the x coordinate is 3. I can put whatever I want in for the y, so I'll just use 0, 1, and 2 for the y's. So 3, 0 is right here, 3, 1, 3, 2. So hey, this is a vertical line. And if you have that memorized and you don't need to make up points, that is fine, but just giving you a technique. If you forget, then you can always figure it out like that. Okay, so there's my boundary line, and let's choose a test point again. I'm going to test 0, 0. Okay, so I'm plugging that in for x and y. Well, there's nowhere to plug in the y, so I'll just plug in the x then. So I get 0 is less than or equal to 3, and I'm thinking, is that true or false? 0 is less than 3, so that's true. So that's my true side. This is my false side. I forgot to put that's my false side. You don't need to put T and F. I'm just doing that for explanation purposes. But then I'm shading the true side. So this is where going to be all of the x, y pairs here. The x is less than or equal to 3. Over here, they're not less than or equal to 3. So that's why I have that side shaded. Let's look at an application. In other words, a word problem. Okay, so we're going to look at a situation where we have, we're going to buy some red peppers and tomatoes for salsa. Okay, and we've got $12 to spend on the peppers and tomatoes. Okay, so let's first make up some variables for red peppers and tomatoes. Well, I can see red peppers is on the x-axis, so let's have this be our x, and then tomatoes is on the y-axis, so tomatoes can be the y, okay? So let's think about how much this is going to cost. So red peppers cost $4 per pound, okay? So for each pound of red peppers, and X is the pound of red peppers, we're going to have to spend $4, right? And then the tomatoes are $3 per pound. And pounds of tomatoes are Y. So this is going to be the amount of money that I spend on the red peppers, and that's the amount I spend on the tomatoes. And I know I've got a total of $12. Doesn't mean you have to spend all $12, but that's the maximum that you can spend, right? So the amount of money we spend has to be less than or equal to 12. And now I've got my inequality, okay? And now I'm going to graph this. And so I've only got I'm only going the positive direction on the x-axis and the y-axis because you can't have a negative amount of red peppers or a negative amount of potatoes, right? So we're only dealing in the positive numbers here, okay? So I'm going to graph the boundary line, which is going to be solid here. Okay, so I'm going to put this in y equals mx plus b form. And I'm actually just going to leave this as an inequality symbol instead of an equal sign this time, so that I can show you that the shortcut from before will work here. All right, so 3y is less than or equal. I want to put the negative 4x in front of the 12, like that. Those aren't like terms, so I can't combine them. But now I want to get this isolated. I want to isolate the y. So I'm going to divide everything by 3, and I've got y is less than or equal to negative 4/3 x plus 4, okay? So my slope, I can think about that as negative 4/3 or 4/-3. And my y-intercept then is going to be 4, okay? And I'm going to do this with a solid line. So yeah, y-intercept of 4, and from there I'm going to go down 4 to the right 3, okay? And then I'm going to connect those. This time I'm going to use a line segment because, again, I can't go into the negatives on either of those variables. And then I've got to shade one side of this to see all the combinations, okay? So let's pick a test point. I'll pick... well, let's use this point, 1, 1, as a test point here, okay? So I'm going to go to the original inequality, and I'm going to plug this in for x and y. So I've got 4 times 1 plus 3 times 1 is less than or equal to 12. Okay, and when we do the math here, this is going to be 4 plus 3, that's 7. 7 is less than or equal to 12. Well, that's true. And so that means that this is on the true side. This must be the false side. And we'll shade the true side. Okay. So that means these are all different combinations. If we bought 1 pound of each, then we would only have spent 7 of our $12. So that works, right? We could get 1 pound of red peppers, 2 pounds of tomatoes, or 2 pounds of red peppers, 1 pound of tomatoes. And, you know, it doesn't have to be integers. We could get 1.5 pounds of something. And so any XY pair, including the fractions and decimals in this zone, are a possibility. We could get 2 pounds of red peppers and no tomatoes. It'd just be red pepper salsa, which would be weird, but I guess you could do that. Okay. So there we go. That's the end of the section, and I'll see you next time.